All right, welcome back to Lag Demon Programming. Today we're going to take a look at a really, really powerful and free tool that's very similar and has a lot of the capabilities of MATLAB. It's called SciLab. And I'm here on the SciLab page. I'm going to show you where you can download it and install it. It's pretty straightforward. Just download it for your system and install it. I'm not going to go through the details of that, but it's at scilab.org. And the link will be down in the description. And we're using SciLab 6.1.0. If you just click on this version here, you'll see that you can install it for Windows Vista 7, 8, or 10, and a couple of versions of Linux for Linux, 64 and 32-bit Linux, and Mac OS. So I'll leave that to you. You should know how to install software. If you want to follow along with this, install SciLab 6.1.0. On your system. So let's get right into it and bring up SciLab and start talking about it a little bit. So I'm going to fire it up here, and you'll see that it's SciLab 6.1.0. And so sometime in the future, if there's newer ones out, there may be slight changes, but they're usually pretty minor. I've already got some stuff displayed here just to give you a tour of what's available. Your screen will not come up like this. I've set up my environment in a certain way. Later, I will show you how to arrange windows and set things up how you want them. But I've got actually SciLab and XCos combined here in a single window to make it easier to record. Just a general tour of it. You have a file browser over here, and I'm going to slide this over a little bit. It doesn't need to take up that much room. And you can go find your project files and other things using this file browser. It's very convenient to have it right there. We'll get into that later when we start saving stuff and making files. This section right here is the SciLab console. And you see it says here loading initial environment, which is the environment that I set up. Having all these windows in this particular position. Don't worry about that. I'll help you arrange them, and then you can arrange them how you like them. Normally, SciLab and XCos are in separate windows, but you can combine them easily. They're all part of the same windowing system. So, in the console here, you'll be able to type commands. There is down here a thing called a variable browser. We'll get into that. I've got these on different tabs. And then this is the palette browser for XCos. This is an XCos window with some modeling stuff in it. And we'll work with that very soon. We're going to start off in the console and just make some variables. So I'm going to pull up the variable browser here and show you that, well, first of all, I guess I should show you a little bit about how to set up the windows. So any of these windows that you'll see there's a blue bar up here. You can drag it around, and you can actually even drag it, pop it clear out, I believe. Let me see here what happened. Oh, that's right. Use this little button here in the corner to pop it out as a window. That makes it a separate window. And that's how XCos will come up when we fire it up. So what I'm going to do is I'm going to close all the XCos stuff for the moment, and XCos that closed. And I'm going to set this kind of up the way it'll come when you get it. You'll probably have the variable browser over here. You'll have this main window over here, and you might have where is it? Where would it be? View. No. Edit, control, resume application. There's the variable browser. Oh, command history. That's one that you'll probably have up. So let me put them. This is sort of akin to how you'll have this. You might have a command history. You can clear that. You know, see, I've typed a lot of commands in here. The variable browser and this. It'll be something like that. And to bring up the XCos application, if you type here XCOS right in the console and hit enter, XCos will come up as two separate windows. This is a palette window, which we'll use for drawing on it, and this is the drawing surface of an untitled file, and we can save these files too. Another feature, I'm going to close this for now. Another feature that you will run into is the Sign Notes, which is a little editor that you can use. And I'm going to cancel this. I don't want to open any of those. And I will bring this down here. It'll open as a separate window as well. And you can put Sign Notes into wherever you want on here just by grabbing the blue bar and dragging it. And we'll put it down here for the moment. And this is where you can edit code, save it as a file, and run it in SciLab. All right. So that's, and then you can, size and arrange these windows as you wish. So let me clear the command history. I believe it's CLR. That clears CLEAR. Clears the variables. And command history off the top of my head. I never really worry about the command history. It's nice to have because it pops them up here with the up and down arrow key, but you can also go back through them and say, well, I want to run this one, and it'll actually run it. And we won't. You can just double click on it and it'll run that command. Another neat little feature, you can see wherever you've done stuff in the past. So you can run clear. Oh, there's clear history. It's over here. So we'll just clear that out. So we've got the history there, and then we can clear the console. So this is how it would look when you first fire it up brand new, more or less. The windows might be in a little bit different position. I don't know. It's been a while since I fired it up brand new. So what can we do here from the console? Well, we can add numbers. We can type in equations like this. 1 plus 2 is 3. 2 times 2 plus 4 times 7 should be 2 times 2 is 4, and 7 is 14, 28. So it should be 4 plus 28 should be 32, and it is. So you see it knows and understands operator precedence. It did the multiplication first, and then it did the addition. It's a pretty smart tool. It knows how to do math, but it knows how to do a lot of other things as well. You can create different kinds of variables. So you notice it created one over here called answer is 32, and that's just a common variable that it creates in there. If we type in A and S and hit enter, we'll get the last answer that we produced from just computations. But we can also create variables like A equals 2 and A equals 2. Now if you don't want to see the printout below where it says A equals 2 dot, we can do this. We can say A equals 4 semicolon, and it just does it, and it does it in a non-verbose way. So let me clear this console again so that we're up here, and if we type in A now and just hit enter without a semicolon, we'll see A is 4. Over here in the variable browser, you'll see we now have an A, and its type is double, it's local, and it uses some it's got some memory. Okay, and you can also look this stuff online. I'll show you where the help material is. You can get the help material right here. In fact, let me pull it over here. So this has tons and tons of material in it. To be honest, some of it's helpful, some of it's less helpful. Unless you really know the technology, they don't necessarily write up a lot of details in this, but this is a good reference and gets you where you want to go with things. I'm going to close that for now. This idea of variables like B equals 6, and then we can go A times B, and it multiplies A and B and gives an answer. We can also say C equals A times B, and we get a new variable, C. Okay? So those are simple scalars. They're double values, and they're simple scalars. What if we want to create a vector or a matrix? Well, let's start with a matrix. If we start with an open square bracket and we put numbers in, 1, comma 2, comma 3, and then we put a semicolon, and we go 4, comma 5, comma 6, and a semicolon, and then 7, comma 8, comma 9, and then close that. That is a matrix, and you notice it prints it out as a matrix: 1, 2, 3, 4, 5, 6. So with the commas, it's a row, and between the semicolons is each 1, 2, 3 is a complete row, right? And then the next row, and then the next row, and these numbers are the columns. Well, there's a little easier way to do this to keep track of it. If we put an open brace and we just go 1, 3, 5, and then hit enter, we can put in the next row. We can put in 2, 4, 6, and hit enter, and we can put 7, 8, 9, and then close bracket, and there we entered a matrix that way. And sometimes it's a little easier to understand what your rows and columns of your matrix are. Okay. You can, of course, assign these to variables. We can say that, A, we can make a column vector by going 1, semicolon, 2, semicolon, 3. Oops, A equals. So there's a column vector. And then we can make a row vector, B equals 4, 5, 6, like that. 2, 4, 6 rather. And then we could do something like A times B. And it gets a matrix. That just did, it took A, which is a column vector, and B, which is a row vector, and it multiplied them. Well, what happens if we go B times A? We get a scalar. So if you remember your linear algebra, which hopefully you had, because this is not a tutorial on linear algebra, that a column vector multiplied by a row vector is a matrix, but a row vector multiplied by a column vector is a scalar. And you can see that if you just do the multiplication by hand, you can see why that comes out that way. So this is how it can handle linear algebra. It can handle a great many other things, including some stuff with calculus and other things we probably won't get into in this tutorial series. But we are going to use this tool in some of my other videos, and this is why I'm doing a series on this tool, is because, hold on one second. Okay, we're about 12 minutes in. That's good. Because we're going to use it for modeling some of the things that we're going to build, like on the Raspberry Pi and some other stuff. We're going to build some controllers, and this is a brilliant tool for modeling controllers. One other type of thing I want to tell you about that you can create as a type of variable is a structure. So we can go, we'll just call it my struct dot A equals 2, and we can go my struct dot B equals 4. We'll make it 4. Okay, and then we can type in my struct and A equals 2 and B equals 4. And if you look over here, you'll see its data type is struct. Okay, this is going to be important for using certain tools in XCos because they require a struct of a specific kind to send data into them if we want to send it from here. Now, you can do a lot of stuff in this. You can write programs, you can create functions. I'm not going to get into functions right now or creating programs. We're going to do that when we start doing XCos because we're going to create our own blocks using functions. And we're going to assign values to some of our blocks using the variables that we build here and build from code that we run inside this tool. So, with that said, let's bring up XCos and kind of go over some of the basic things it can do for the remainder of this video. And in the next video, we'll start building up some real models. We're going to start simple and move up and walk through some of the capabilities of this system. So we type XCos and hit enter, and we get our two windows. Now, for the moment, so we don't get confused with all this other stuff, I'm just going to take this window. I'm going to pull it off to the side first. I'm going to make this window full screen so that we can see things really well. And then I'm going to take this window here, and I'm going to dock it on the left side of this, and I'm going to squeeze it in. So we got a nice big window with our toolbox built right with it. And this is called Untitled 1. It's XCos. So first thing I'm going to do, and I always do this, I'm going to hit the save button. And now I'm in my SciLab folder, and actually I want to be down in my videos. And in fact, I'm going to have to move this. Where is it? The videos. There it is. And we're going to create a new folder called SciLab. And in SciLab, I'm just going to create a folder that I'm going to call projects. And we'll just use this folder for the moment, and we're going to make it, we're just going to call it test model. Now we'll call it example. Example. And we want it in XCos format, so it should save it as example.xcos. You can see it right here, example.xcos. So XCos is a modeling system that allows you to display things, and so we're going to start with something extremely simple. And I'm going to show you some of the basic things you always have to do. This is my recently used stuff here, and I've got a few of them in here. I'm going to come down here, but I'm not going to use from recently used because I want you to see where these items are. The first thing that we need is a source. And the source, we need a couple sources. We're going to start with a simple sine wave. So we'll grab this guy right here, and we'll just drag and drop him onto the screen. And we're also going to need a clock, and I'll explain that shortly. As long as we're in sources, I'm just going to, it's kind of a habit. When I pull up my sources, I always throw at least one clock on here because I know I'm going to need a clock. Under sinks, this is where things, so a source is where information comes from. A sink is where information goes to. It kind of ends there. And there's a bunch of different kinds of sinks. And we're going to start with this very simple thing here called a C scope. And we're going to pull it over here. I'm going to put it down below this clock. And I'm making this kind of big. I'm going to expand it up so you guys can see everything. I'll pull this in. Pull this down here. Make this a little bit bigger. All right. So hopefully that's much more easy to see. All right. You'll notice there's some little arrows on these. You can only ever hook black to black. And you can hook blackouts to black ends. And there's some ways you can hook multiple things up by connecting the wires. We'll get to that. And red to red. Now, what is this? What's the difference? So this is an event. This clock is producing events. And you can see here, if you hover over it, it's 1-to-1. It tells a little bit about its style and stuff, but mainly it tells about the input. We'll get into that, what the 1-1 means. But these red ones are events, and this is a clock event. So we're going to plug that red one into that. That's the clock that's going to tell the scope how quickly to do things. How many, basically it's a form of how many samples we're going to take. Now on the clock, we can double click it, and it brings this up. So the period is 0.1. So it's going to put out a clock signal every 1/10 of a second, which for our purposes is a little bit granular. So I'm going to make that every 100th of a second. And then this initialization time, we'll talk about that later. Just set that to 0 for now. And then if we hook this signal into here, that's our scope, and that's what's going to display this signal. Let's take a look at this. Its amplitude is 1. Okay. Its frequency in radians is 1 radian per second. So 1 radian per second means it's going to be like this is less than 1 hertz, right? It's taking a whole second to go 1 over 6.28 around the circle, right? So it's going around radians per second is 1. So let's start by just running it and see what it does. And it's going to pop up a window here, and we'll see there's a little sine wave. Now there's a couple things we can do. We can fit this by hitting this button here, and we see a nice sine wave, okay? But I'm going to close this, and I'm going to open up the scope, and I'm going to make a few little adjustments. Well, we know our signal is an amplitude of 1. So let's just set the y min to -1 and the y max to 1. We won't worry about the refresh period right now. We'll talk about that. And we won't worry about other attributes of this for the moment. Just the y min, y max values. While the buffer size, we won't mess with it yet. We'll talk about those later. So all I've done here is scaled the vertical, set the vertical scaling on this. So here you can see now we've got 1 and -1, and that's our amplitude is 1. And of course it's the amplitude of a sine wave, so it's +1 and -1, and it fits perfectly without having to adjust it. So that's just a little overview of how we go about using this modeling tool, connecting things up, taking sources, putting them through some processing, and using clocks. We're about 20 minutes in, and I like to keep these videos to right about 20 minutes, so I'm going to end this video here. This is just kind of an overview. We're not really doing anything, just kind of familiarizing with the tool. I also don't like to spend a lot of time going over every detail of a tool, especially a complex tool like this. I just hit the high points. As we run into and do things, we'll talk about aspects of the tool at each stage. I'm going to go ahead and save this, and then I'm going to close this. And there. So that's kind of an overview of SciLab and XCos. If you like this video, hit that like button. If you really liked it, hit the subscribe button. And I'll see you in the next video. Thanks for watching.